Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is who has the maximum acidity among four. The options are in front of you. I request you please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now question, who has the maximum acidity among four? You see option A, aniline, phenol, amide, benzamide and phthalimide. So I guess you are quite familiar with the first two options like aniline and phenol. Obviously phenol is more acidic. By the way, remember whenever you have such kind of acidity comparison, you need to understand what did they ask? Acidity means H plus releasing capability. And who can release H plus more efficiently? If the conjugate base or the proton released form is more stable, then the proton release will be more efficient. By the way, one important information, previously there was one lone pair on NH. After removal of one proton, there will be two lone pair of NH on NH nitrogen atom. So don't get confused. Now obviously here in case of phenol, you can see that is phenoxide conjugate base. Fine. If you look at the third option, that is amide, means proton abstraction will happen from the NH. So this is NH minus. Now if you look at the fourth one, obviously here also same way this proton will go and ultimately it will produce N minus. Now as I told, the conjugate base theory, remember it's a thumb rule that more the stability of conjugate base, higher will be the acidity. Now if you look at the stability, in this first two example, the stability actually achieved by delocalization of this lone pair inside this benzene nucleus. Actually it was previously, now conjugate base case this part is delocalized. So initially there was delocalization, now after conjugate base formation this way it is delocalized. In case of phenol, similarly lone pair will come and delocalize into the benzene nucleus. Since the oxygen is more electronegative than nitrogen, so phenol is obviously more acidic than aniline. Fine. But next, if you look at option C, in this case the conjugate base is stabilized by such kind of resonance. Okay, so let me draw the canonical form here. Actually here benzene nucleus is not involved in the stabilization of this nitrogen anion NH. So now consequently you can say, okay sir, this is stabilized. Now what about the fourth one? Fourth one is pretty interesting, student. So these lone pair could be stabilized this way. So this is the benzene ring, this is O minus, this is nitrogen, double bond O, this. Now there could be another kind of resonance stabilization too. What do I mean? So you can expect that this lone pair can come here and it can open. So I am drawing this canonical form here. So this is the benzene nucleus, this is a 5-member ring, double bond O minus. By the way student, I give you one suggestion, please draw such kind of structure by yourself on pen and paper, then only this theory will be in your mind completely. Okay, so now this much you understand. So one thing is clear, that first of all, if you delocalize within this benzene ring, the aromaticity of this benzene ring is disturbed somehow. The stabilization of conjugate base if you consider. Now if you look at option C and D, here this part, this stabilization does not affect or involve the benzene ring. Consequently, benzene's aromatic stability is not hampered. Fine. Now if you look at this, compare C versus D option. So the conjugate base produced from option D is doubly stabilized by resonance. I repeat the word. The conjugate base is doubly stabilized by resonance by the conjugation of two carbonyl group. So consequently, actually this D option is, student, acidic, maximum acidic. And if I give you a comparison, pKa value experimentally, so you can see that the pKa of this phthalimide is minimum. Lesser the pKa, remember this rule, lesser the pKa, higher the acidity. Okay, so this is more acidic option D. Now you say, sir, if you compare phenol versus phenol's pK 9.95, So this is actually more acidic compared to amide. Yes, true. Actually, these amides are called neutral. They are generally are not called as acidic. They are called neutral molecule. Amines generally they are called basic. And by the way, this ammonia is a weakly basic molecule. By the way, I did not find the value of the NH bonds pK. So I request you, if you know this value, please share me. In internet also I didn't get it. So but we know that B, I mean phenol, is actually more acidic compared to NH2, and this option D is more acidic compared to phenol. So this is maximum acidic. So actually, if the question is asked what is the trend, so trend is actually D greater than B greater than, it's very difficult to say unless I know the value, but obviously amines are relatively more basic compared to amides, so I can expect like that A greater than C. So D, B, A, C, this is the expected value. If you know the exact pKa value, please let me know, then we can comment on this more accurately. So what is the answer of today's question? Maximum acidic among 4 is this one, phthalimide. Okay, so this is the end of discussion. I believe this is very useful. Thanks for watching. See you in my next video. Bye bye.